All right, hello Algebra 1. Today, we're going to skip over 7.2 for today, and we're going to go to 7.3, and we're going to graph these kind of quadratics today. These look real funky, but these are called vertex form quadratics. Let me turn that down. All right, they're vertex form quadratics, and the reason they're called that is because you can immediately decipher the vertex of the parabola immediately. Now, again, Desmos would be helpful to kind of discover this, but we're just going to tell you right away that if you've got an equation written in vertex form with this parentheses and the squared, then your vertex is going to be found by doing the opposite of the number in here. So your vertex would be the opposite of negative h, so it'd be h. And then the y value is going to be this k right here. You're going to be able to get your vertex right away, super quick. And they use kind of an illustration to show you here that if you move a graph, so here's kind of like a parent graph, but if you subtract if you move it over h, that impacts the equation by subtracting an h in here. And then if you move it up k, it has the impact of adding a k value at the end. So it's really funky how this works, but it's the reverse of what you'd think. So it's kind of interesting. So let's kind of throw an example out here. So if we had a 1/3 out front, that would mean that it's a vertical shrink by a factor of 1/3. But if as soon as we put a -3 in parentheses squared, that means it's translating it right 3. And then when we put a -4 at the back, it's moving it down 4. So our new vertex would be at 3, -4. And then to graph, we just make a table of values and get a couple more points, and we would have our parabola. So I gotta admit, this is my favorite form to graph from, okay? And you can totally use this for what we did before. We were graphing these types right here. But check this out. Your vertex would be at 0 because there's no h in there that they're subtracting or adding. There's nothing in there. So your vertex would be at 0c. 0c would be your vertex. And you could do these exactly like what we're going to do today, what we did yesterday. And it saves you a little bit of work. Not a lot, but it would save you a little bit of work. So let's see this in action. It says to graph this equation right here. It's weird looking, but that's because it's in vertex form. And they want us to compare it to the parent graph. So the first things first is to identify the vertex. So you're going to go opposites. This +2 means that they moved it left 2. So our vertex is going to be -2 up 3. -2, 3. That's our vertex. We got that quick, super quick. All right, super quick. So there's our vertex. And then your axis of symmetry is this line running down the middle of it. Now that has a name. It's x equals -2 is our axis of symmetry. It's the equation of a line. Okay, so now what we're going to do is find an additional point and y-intercept. I don't care about that. Okay, what we need to do is we need to graph this. Now, I happen to know from yesterday that because there's a negative out front, it's going to be flipped over. So I know it's going to be flipped over. I know that 2 is bigger than 1, so it's going to be a vertical stretch. And then from yesterday, I know that this +3 moves it up 3. Okay, so I'm kind of ready for all that. But let's just get 2 more points that are either 2 to the right or 2 to the left of the vertex. And then we're going to be able to mirror it, reflect it over, and we'll be able to get the rest of our parabola. Because remember, these parabolas are all U-shaped. So because our axis of symmetry is at -2, I'm going to go easy. I'm going to go to the right one and then right one more. So it'll be at -1 and 0. I'm going to use -1 and 0 here. So I got to plug that into the original equation. And you are welcome to use a calculator to figure this out. I'm going to try to do it in my head. This would be 1. Squared is 1. Get -2 plus 3, which is 1. And then we got to plug in a 0 in for x. This would be 4, -8, -8 and 3. It's -5. All right. Whew. Again, you're welcome to use a calculator. And we go over here, we go -1 up 1. 0 down 5. Yeah, there we go. Now class, that's not a parabola. That's half of a parabola. Reflect it over and you get a full parabola. Like so. And that, class, is how it's done. So just to recap, get your vertex right away, and that also gets you your axis of symmetry. Then get 2 more points to the left or to the right of your axis of symmetry, and you are done. 2 more points to the left or right, and you're going to be great. I think maybe you might want to write that down. Use 2 points to the left or right of your axis of symmetry. And yeah, we got it. So now, class, we should probably be thinking about like domain and range and things like that. The domain for this would be all real numbers. We should probably be talking about that. It goes to the left and right forever. So our x values go left and right forever. So that means our inputs are all real numbers. Our range, or our outputs, is everything below this, right? It's going down forever, but it's below this value. So that's going to be y is less than or equal to 3 would be our range for that. Okay, so class, for some reason it said find an additional point and the y-intercept. Well, we did find the y-intercept. The y-intercept is where it crosses the y-axis, and that was at 1, 2, 3, 4, 5. -5. Y equals -5 was our y-intercept. But I don't care about that. Just find 2 more points to the left or 2 more points to the right, reflect it, and you'll have a nice parabola. Okay, what else could we talk about here? Okay, not a lot of practice on this these notes here, so make sure to work on your practice sheet, your homework sheet. Get some reps in. Okay, they want us to graph it. They want us to identify the vertex and the axis of symmetry. No worries. They want us to say the minimum or maximum value. Nice. Okay, and they also want us to find the y-intercept. I don't know if we'll do that. Okay, we may skip that. It doesn't really help us. Okay, so class, vertex right away. Vertex right away. -4, opposite, right? -4, -2. So opposite right there, same right here. So it's -4, -2. And then, yeah, I would graph that thing. -4 down 2. Our axis of symmetry is going to be right down here like that. And then we just need 2 more points to get our graph. Since we're at -4, I'm going to go -3 and -2. And we got a little bit of work to do. 1/2 -3 plus 4 squared minus 2. 1/2 -2 plus 4 squared minus 2. And you're welcome to grab a calculator. It's not a bad idea at all. If I grab my calculator, I would, well, I mean, I'll do it by hand, I guess. So, oh, yeah, okay, I think this makes sense. -1.5. Your calculator might say -3/2. I would make that a mixed number. It'll be easier to graph. It's -1.5. And then this one is interesting because that'll be 2 squared is 4. Half of 4 is 2. 2 minus 2, it's 0. And again, you're welcome to use your calculator. Let's plot these points. -3 down 1.5. And then I'm just going to go ahead and reflect it over. -2, 0. And I'm just going to reflect it over. And then we got a parabola, everybody. Parabola. And so class, our axis of symmetry was x equals -4. Was our axis of symmetry. They wanted the vertex axis of symmetry, minimum or maximum value. Well, class, this is opening up. So it's going to have a minimum value. A minimum value at -4. So it's going to have a minimum value at y equals -4. And they also wanted the y-intercept, and I'll be honest with you, I don't care. I'm just going to ignore that. All right. So class, it's important that you practice here because we just haven't done many reps, right? You want to do a few of these on your own and make sure that you understand it. We've got one more way to learn how to graph parabolas. So that's coming up in our next lesson. Oh, before we leave, let's get domain and range real quick because I want you to see that. Domain, all real numbers, goes forever left, forever right. Range, it doesn't go forever up and down. It starts at -2 and goes up. So we say y is greater than or equal to -2. And yeah, so that's it. So hopefully this is clicking for you. Have a good day.